Hello students. So today we will be continuing with the chemical properties of this diazonium salts, and in particular we are discussing about benzene diazonium chloride. So today we will be discussing about replacement by, and this is the continuation from the previous video. Okay, so replacement by chlorine or bromine. Okay, in our previous video we had discussed replacement of this group N2 plus Cl minus group. This entire group, replacement of this entire group with hydrogen, with OH minus OH ion and nitro group, as well as fluorine. We had discussed with fluorine. Okay, and why did we discuss with fluorine? Because the reaction of replacement by fluorine and replacement by nitro group was almost similar. Today we will be discussing replacement of this N2 plus Cl minus with chlorine or bromine. And don't forget, replacement by bromine or chlorine is known as what? Saint-Mears reaction and Gattermann reaction, which we had discussed before. There is a slight difference there, just in the use of the catalyst. Okay? In our previous video where we had discussed about replacement by fluorine, that particular reaction is also known as what? Bose-Simon reaction. So at first let's discuss replacement by chlorine first. Okay, now this group can be replaced with, say, chlorine by treating with cuprous chloride, Cu2 Cl2 in presence of, say, HCl. Now this benzene diazonium chloride, okay, benzene diazonium chloride, whenever it is treated with Cu2 Cl2 in presence of what? HCl, and if it is heated, what will happen? Replacement of this N2 plus Cl minus takes place with chlorine. So here we have what? Chlorine. Therefore this is what? Chlorobenzene. And the byproducts are nitrogen gas. Now whenever you are using this Cu2 Cl2 and getting chlorobenzene, then this particular reaction is known as what? Saint-Mears reaction. Don't forget. Okay, this is cuprous chloride. Whenever you are using cuprous chloride, then this reaction is known as what? Saint-Mears reaction. And this we have discussed before also. Saint-Mears reaction. Okay? Now if you want to substitute with, say, here, instead of chlorine, you want to substitute with bromine. Then what you have to do? You just have to replace this chlorine with Br2, and here also, in place of HCl, you have to use what? HBr. Now, since here we have used cuprous bromide now, this is not chloride, this is bromide. And what will happen? This Cl will be replaced by what? Will be replaced by Br. And as a result, we get what? We get, instead of chloro, we will be getting now bromobenzene. And this is again known as what? Saint-Mears reaction. Please don't forget, whenever you are using this part, cuprous chloride or cuprous bromide, and getting accordingly either chlorobenzene or bromobenzene, then these reactions are known as what? Saint-Beuer's reaction. Okay? Now let's discuss about Gattermann reaction. Now what is Gattermann reaction? These two reactions are almost similar. The products are same, the starting material is same, but a slight difference is there. Okay? In case of, now we will be discussing about Gattermann reaction. Now in case of Gattermann reaction, and this Gattermann reaction, in case of Gattermann reaction, here instead of cuprous chloride or cuprous bromide, we will be using only copper, say, powder. Okay? Now, only a slight difference is there. Instead of cuprous bromide or chloride, here what are we going to use? We are going to use copper powder. So if you just use copper powder, then this is known as what? Gattermann reaction. So if you use HBr, you will be getting bromobenzene. Okay? Now if you use HCl, then what will you get? You would be getting, say, here if you are using HCl, you will be getting chlorobenzene. So there is a slight difference only in between Saint-Beuer's reaction and Gattermann reaction. So hope this is clear. And these reactions we have done in our classics, in our everyday classics, in the first chapter of organic chemistry. Now let's discuss about coupling reaction. Coupling reaction of benzene diazonium chlorides. Coupling reactions are also known as what? Azo-dye reaction. Azo-dye reaction. Why? Because now whenever this benzene diazonium chlorides are coupled with other compounds, we get what? We get dye. We get dye means we get some colored compound. So in our cells we have a coupling reaction of benzene diazonium chloride with phenol. Okay? With what? Phenol. So let's discuss first that. So here what we have? Benzene diazonium chloride. Now let me write here as N triple bond N and Cl minus. Now this is positive. This is N2 Cl minus itself. But here the valency of this nitrogen has to be maintained. Therefore nitrogen and nitrogen forms a triple bond. Please don't forget this part. Okay. Now we will be writing in this form. Now, whenever it is treated with say phenol, the structure of phenol is OH. This is phenol, and this is your ortho position. This is meta position, and this is para position. Now, this benzene diazonium chloride reacts with phenol at its para position. Please remember at which position? At para position. The hydrogen from para position and this chloride will get eliminated as, let me write here, as HCl, and these two compounds, now they are what? Condensed. They form bonding between them. So let me start from here, this side. So here, what do I have? I have got N. Now, since these compounds are left, it eliminates. Then one of the triple bonds from here will be used in bond formation between this nitrogen and this carbon at para position of what? Phenol. Therefore, here now in the product, what you have, instead of triple bond, you will be having double bond. So double bond N, and this one bond has been shifted this side to form bonding with this para position of the phenol. Okay, so you get this compound. You will be getting this compound, and this is which color? This is phenol, and it is orange color, and it is also known as what? Phenol orange. Therefore, these reactions are also known as what? Azure dye reaction, because they give us colored dyes. Now here, the pH value has to be between, for this reaction, the pH value has to be between 9 to 10. Okay? This reaction, see, whenever you look at first, it looks like it's a difficult one, but if you go for understanding it, this is very simple. This compound, you know the structure of phenol. You just eliminated HCl, and please don't forget this nitrogen will be bonded to the para position of the phenol. So here this nitrogen is now bonded to para position. Okay? Now if you understand this reaction, one more reaction is there in your syllabus where this coupling reaction of benzene diazonium chloride takes place with what? With aniline. Please don't forget the color of this dyes. Now it is reacting with what? With aniline. So let me write this aniline first. NCl minus. So aniline, for aniline also, it is going to react from the para position. Please don't forget. This is the formula of aniline. Again, the same type of reaction takes place. This HCl is removed. As in the previous case, here also, what will happen? Bonding between this nitrogen and the para position carbon of aniline takes place to give you a condensed compound which has some characteristic color. So let me write the product first. And here we have NH2. And the color of this one, this compound, this dye it's yellow in color. So it is also known as aniline yellow. So if you want to remember the name, you have to remember name. If you want to remember the color of the dye, you remember this way. Aniline gives you yellow dye. So with this, we come to the end of this chapter. In the next video, we will be starting with the new chapter. Till then, your responsibility is there. All the ISC questions, please practice them properly. Practice them, write them, and WhatsApp me for this analyzing and whether it is correct or not for that purpose. Okay, till then, take care. Bye.